channel, where science, technology, engineering, and math are made easy. Today we're going to be learning about resistors. So what are resistors? Well, in electronics, resistors are electrical components that limit current. Now, current is the flow of electricity through a circuit. The resistors exist to protect the different components and the circuit itself from being overheated and exploding or just failing, because certain components can only handle so much current. And I'm going to show you this right here. So I'm going to introduce the 9-volt battery, the circuit board, the resistor, and the LED, which I'll explain in a moment. So I'm going to move the battery and the circuit board into place. Now, in electronics, electricity always flows from positive to negative. So it starts in the positive, oftentimes called the bus bar, to the negative bus bar, oftentimes called ground. So we're going to connect the positive bus bar to the positive side of the battery. Then we're going to connect the negative side of the battery to the negative bus bar or ground. It's going to take me a second to move it into position. Okay. Now I'm going to connect the positive bus bar to the circuit board with some wires. Now I'm going to introduce the resistor, and I'm going to connect it to the LED. Now an LED stands for light emitting diode. It's like a Christmas light. And LEDs have two sides, a anode and a cathode. Now anode is positive and cathode is negative. Since electricity flows from positive to negative, we're going to put the anode first. See the anodes first and then the cathode, and I'm going to tie the cathode to the negative bus bar or ground. When I start the stimulation, you figure out why an LED is called a light emitting diode. Now let's pretend that this resistor doesn't exist in the circuit and we just have wires connecting everything. It should work, right? Wrong. The resistor stops some of the current to protect the LED. The LED cannot handle all the current from the 9-volt battery at once. It needs something to protect it. Since the resistor isn't there, it explodes. So back to here. You've probably noticed this, the 4-band resistor color chart. And you're probably wondering how to interpret it. Well, as you can see, we start with color. Black, brown, red, orange, yellow, green, blue, white. And these all have value. This right here is the first digit. It's a 1 since it's a brown. Right here is a second digit. Since it's a black, it's a 0. Now the third digit is the multiplier. So we have brown, which is 1, black, which is 0, and brown, which is 1. Now, based off that, you would probably say it's a 101 ohm resistor. Right here it says it's a 100 ohm resistor. And what this basically means is you take the first two digits at face value, the brown is 1, the black is 0. And the third digit is a multiplier. Since brown is 1, you only add 1, 0. So that's why it's 100 ohms. So let's imagine that if it's a brown, black, red resistor, the brown would be 1, the black would be 0, and the red would be 2. So it'd be a 1000 ohm resistor. The third digit just determines how many zeros you add to it. So let's go down and do some problems. So here's the reference sheet. 1000 ohms equals 1 kilo ohm, and this is a symbol for ohms. So let's start with kilo ohms to ohms for our conversions. So you have a 3300 kilo ohm, 3.3 kilo ohm, you have 3300 ohms. Going to move that into position. So you have a 4.7k ohm, you have 4,700 ohms. Suppose you have 10k ohms, well you have 10,000 ohms. So now let's do from ohms to kilo ohms. If you have 5,000 ohms, you have 5 kilo ohms. Suppose you have 2,200 kilo ohms, well you have 2.2 kilo ohms. It's going to take me a second to, okay. Suppose you have 15,000 kilo ohms, you would have 15 kilo ohms. Now from these values alone, what are the resistor color code? And I'm going to do it for all of them. So let's start with the first one, 3.3 kilo ohms. Well, a 3 is an orange, and since you have 0.3, you have another orange. And since you have two zeros and 3,300 ohms, it would be red. So it's orange, orange, red. Orange, orange, red. I wonder where that comes from. The zero, whatever that is. Suppose you have 4.7 kilo ohms. Well, a yellow is a 4, and a violet is a 7, and a red represents the two zeros. So it's yellow, violet, red. Forgive me, my battery's going down, and yeah, that's why the screen darkened for a quick second. So for C, we have 10,000 kilo ohms. So of a brown, which is a 1, a black, which is a 0, and since it's 10,000, it has three zeros, so orange. So brown, black, orange. Now for D, we have 5,000 ohms. So it'd be green, black, red. Green, black, red. For number E, we have 2,200 ohms. So the two twos are red and the two zeros are red. So it's just red, red, red. For F, we have 15,000 ohms. So the 1 is a brown, the 5 is a green, and the three zeros are orange. So it's brown, green, orange. Brown, green, orange. Now let's look at some pictures. This will make more sense. What's the value of the resistor? So if we have brown, which is a 1, a black, which is a 0, and a red, which is a 2. So it's 1, 0, and the third one's a red. It's the multiplier, so 1,000 ohms. Or 1 kilo ohm. Now the second question is asking about tolerance. Well, what is that? Well, up here, you have tolerance. Gold is 5% and silver is 10%. Now, all of these I'm about to show you are all gold, so we're going to be focusing on the 5%. So we're going to find the 5% of 1,000. So beforehand, I'm going to find 5%. 5% of 1,000 is 50. Now, what's the value between the resistor? Well, we're going to take 1,000 and minus 50 to get 950. 2, 1,000 plus 50 is 1,050. So it's between 950 to 1,050 ohms. So what's the value of this resistor? Let me zoom in. So it's green, blue, brown. So the green is 5, brown is 1, so 5, 1, and since it's a brown, you just add another 0 ohms, 510 ohms. So what is the tolerance? Well, we're going to take 5% of 510 ohms, since 5% is associated with gold and the fourth band is gold. So we have 510 times 5%. So the tolerance is 25.5. So we're going to take 510 minus 25.5, and that gets us 484.5. 2, move this over here, 510 plus 25.5, 535.5 ohms. Now when I write ohms here, it's referring to both values. It's referring to this value and this value. So let's go on to the final one. The so the value of the resistor, okay, so it's a red, red, brown, gold. So it's a 220 ohm resistor. The tolerance is, so we're going to find 5% of 220. 5% of 220 is 11. So 220 minus 11 is 209 ohms. 220 plus 11 is 231 ohms. Now, why do resistors have tolerances? Well, these things are mass produced, so they're not going to have exactly the same value. They're going to have the value between the tolerance, usually towards the center. And folks, that's all I have for you today. Thank you very much for watching. Please tell me how I can improve, and the link in the description of this video is a link to a website that I've made. It's very new. I'm not going to update it for a very long time. Just give me your thoughts on that. Thank you very much.